So we are in the section 5.2 notes for Math 120, and these are, in case we ran out of class time, going over a few examples. So I'm going to skip this first example and go to the second one. It says the peak of a mountain is 21,345 feet above sea level. The floor of a valley is 537 feet below sea level. What is the difference in elevation between the peak of the mountain and the floor of the valley? So one of the key words in here is difference, and difference is a key word for subtraction. So with this problem, I'm going to draw a picture. They tell us that there's a mountain and a valley. And if I look for some information, they tell me that the peak of the mountain, so that's the very top of the mountain, is 21,345 feet above sea level. So we have 21,345 feet labeled on my mountain. And if it's above sea level, I need to kind of mark off sea level. And in these problems, sea level is always 0. The other thing they tell us is that the floor of the valley is 357 feet below sea level. So that's down here. And we can just label it with the number. But there is a difference between our mountain and our valley. The mountain is above sea level. So because of that, it's a positive number. And because our valley is below sea level, it needs to be a negative number. So this will be negative 537 feet. So if we look back at what the question asked us, they asked for the difference, or that subtraction keyword, between the peak of the mountain and the floor of the valley. So difference does not tell us to switch the order around. So we would do whatever the mountain is minus that valley. So in this case, we'll have our 21,345 feet for the mountain minus that valley, the negative 537 feet. And remember, whenever you have minus a negative, you can do your same change. It's the same as adding a positive. So when we add these two numbers up, we really get 21,882 feet. That is the difference between the bottom of the valley and the top of the mountain. We're going to skip ahead to example 4, which says, find the area of a rectangle with a length of 7 feet and a width of 9 feet. So same thing, I'm going to start by drawing a picture. And they tell us that it's a rectangle, so I'll draw a rectangle. And they tell us two things about this rectangle, that it has a length of 7 feet and a width of 9 feet. So I'll label 7 feet and 9 feet. And you really only have to label two sides, but you can remember that in rectangles, opposite sides are always equal. So this side down here also has to be 9 feet, and this side over here also has to be 7 feet. Now they told us to find the area, so that requires you memorizing a formula. The area of a rectangle is its length times its width. And a lot of times we'll just abbreviate that L times W. So in this problem, our length is 7 feet and our width is 9 feet. So we multiply those numbers out. Our 7 times 9 is 63. And we're also multiplying those units. So feet times feet gives us square feet, or feet squared. And you can write it that way with the exponent, or you can write it out in words. Either way is completely correct. So the area of this rectangle is 63 square feet. That is it for our section 5.2 notes.